Okay, just to recap a few things we've been doing last week and this week. We've been doing a bunch of weird graphs, a bunch of weird shapes. We've got one today and we got one tomorrow. The first one we did was quadratic. After doing all that quadratic formula stuff, if you graph a quadratic, which is y equals x squared, what does it look like?
Y equals x squared,
Yeah.
it goes to the right.
What's the shape for a quadratic?
A parabola.
Parabola or the U-shape. Remember, y equals x squared.
Oh, yeah.
I think the one you're thinking of is the next one, which is the
Yeah.
square root graph.
Yeah.
So what's the square root graph look like?
Does the tail thing?
The dot with the tail. And then the one we did yesterday, that was really, really easy. The one we did yesterday was absolute value. It looked like what? A V. So quadratics give you a parabola. A square root gives you the dot with the tail. And then if you did an absolute value, you end up getting this V shape. The one we're doing today is kind of the same as square roots. We're going to call them nth roots. A square root is like a 2 root. We're going to look at 4th roots and 5th roots and 6th roots and 7th roots, and they're going to all be different. Well, some of them will look the same, some will be different. All right, first thing is, let's put in y equals the square root of x. What did you say that thing looked like? The square root one.
Dot.
The dot with the tail. It has that vertex, and it goes this way. Now, here's what I'm going to show you. On the graphing calculator, obviously we have a button. We can graph the square root of x really easy by hitting this right here. You know, so if I wanted y equals the square root of x, I'll hit my y equals button. I'll clear that stuff out. And I'll put square root x. Of course, that's what it looks like. Kind of starts right at the origin and shoots over there to the right. What I want to show you is that any even root is going to look very similar to this. The shape will change slightly. So like a 4th root, it'll still come out this way. Maybe it doesn't go as high. What I want is to, let's go back to y equals. So everybody go on your y equals. Now on these newer calculators, since we don't have a 4th root button, if you hit math, there's all sorts of crazy options in there. So hit the math button, and what you see is we use cube roots, we use square roots so much that they have a button for it, but cube roots has its own kind of like virtual button, and then this is for anything weird, 4th roots, 5th roots, 19th roots. What I want is everybody over here, I want you to put in the 4th root of x on your graph. And I want everybody here to put the 6th root, and then I want everybody else to put in the 8th root. So hit this button. You guys are going to do the 6th root, or you guys are doing the 4th root. You guys here are going to do the 6th root. Hold on to it one sec. I'll take it. And then everybody else do the 8th root.
Wait, are we doing the 4th root over
You
here?
guys up against the wall over here are going to do the 4th root. And I'll just go ahead and do the 10th root.
Oh.
Good. Okay.
Okay, so first one, we know that the square root looks like this. If we have the 4th root, let me see one of the 4th roots. Here's the 4th root. This is one of the 4th root. Similar. What's the 6th root look like? 6th root. There's the 4th root. Here's the 6th root. And did you got the 8th root in there?
Yeah.
And then the 8th root. So you can see how they're going to be pretty similar. Any even number root, the square root, the 4th root, the 6th root, the 8th root, or even mine, I put a 10th root in there. It's the dot with the tail. It just kind of gets a little bit lower each time. But it's the same premise. We're going to have this dot with the tail. It's the same shape. It's nothing new. So the square root graph and the 4th root graph and the 6th root graph and the 8th root graph all look like this basically. Now the odd roots though, because there's odd numbers, they're not just even numbers, the odd number roots are going to be a little bit different. So use your graphing calculator. Let's put in the cube root of x. So hitting that same thing. And since we have a cube root button, we can just go ahead and hit that. Put the cube root of x. And what I call this one is a sideways squiggle. Now, if you took this away, it's basically the same as that. It's the dot with the tail this way. But it adds this additional part that goes this way. So it basically comes from the third quadrant, hits the origin, and goes that way. So it's a sideways squiggle. So kind of sketch that on there, coming from the third quadrant, and then arc up, and then it's kind of like the dot with the tail going that way. But the vertex of this is going to be the origin. Because remember, as we move the shapes around, we move them up and down and left and right, this is going to be the dot that we move up and down and left and right.
So 0, 0.
So it's still at 0, 0. And then just a side note, since I've got it on the notes right here, one thing that I want you to remember is a cube root is the same as a 1/3 power. So you could graph it like this, since now you know how. But if you didn't, you could graph this instead. The third root is the same as x to the 1/3 power. That's the same thing as a third root. A square root is a 1/2 power, a cube root is a 1/3 power, a fourth root is a 1/4 power, and it's the same picture. So just keep that in mind. All right, let's look at some examples, and without the graphing calculator, let's see if we can figure out what these things might look like. All right, it's going to be mixed up between even roots and odd roots. First thing to say is this an even root or an odd root? Okay. I know that my handwriting is not the best, but that's 3 really. Make it more 3-ish if we need to. All right, so it's an odd root. What shape does the odd root give us? The squiggle, the sideways squiggle. So just put over here that we got odd root. The difference between even roots and odd roots, the even roots are the dots with tails, and the odd roots are the sideways squiggle. Now, we've got some shifting here though. Inside the root, I've got an x minus 2. So how does that shift me?
You go right 2.
Yeah. This is a left-right shift, but opposite what that says. So it's really right 2. Now, outside I got a +1, and that means what?
Up 1.
Up 1. There's nothing opposite about outside. Outside is up and down, just like it says. So let's go right 2 and up 1. So the vertex of this sideways squiggle is right there.
2, 1.
Just 2, 1. And then put that same sideways squiggle in from the last page where we came from here. Just kind of come from here up to that dot. And then go from that dot and go this way. So you got your squiggle in. And I'll go ahead and put it in here. Okay, so I actually grabbed on the graphing calculator, put it in like that. Comes from the third quadrant to the 0.21, and then it changes. All right, let's look at the next one. Lots of things happening on this. First thing is, what kind of shape is this?
A dot with the tail.
Dot with the tail, because this is even root, just like a square root. And let's talk about everything we know. The inside says +3, so what's that going to do?
Left 3.
So I want a left 3. Then outside I got a -2,
Down 2.
down 2. And I got one other thing that you need to take note of right here.
Negative.
The negative does what?
Flips it the other way. The other way.
Yeah, so we'll have a flip. So keep that in mind right before we graph it. We're going to flip. So go left 3. Down 2. Here's this dot. What is this dot right there?
The vertex.
Yeah, which is
Negative 3, negative 2.
and -3, -2, left 3, down 2. Now normally, on even roots, normally I would do this. I'd go here, I'd go like this, I'd go this way. But because of that flip, instead of going this way, I'm going to go down. It's like you take this, fold it over, and flip it down, so it goes down. So it should look like this. I'll try to quickly get that put in here. Okay, so this is what it looks like on your graphing calculator. Kind of weird because it just kind of starts out in the middle of nowhere and then tails off this way. And uno mas on this. First thing is to notice the type of root. We have an even root or odd root?
Odd.
Odd root.
Squiggly.
So we got the sideways squiggle. Inside here is a plus 6.
It's gonna be negative 6.
So left 6. And outside here is a plus 4.
Up 4.
Up 4, so I'm going to do my left 6. My up 4. Puts me here, puts the vertex at negative 6, positive 4. And this one is an odd root. The odd root is the sideways squiggle, but what does that do?
It flips it.
So here's what I normally would do. Normally, I'd come from here and go to here, and then go up. I'm going to do the opposite. Instead, I'm going to come from above it and come here and go down. So instead of coming from below it and going like that, I'll come from above it and go this way. So come from above the dot, and when we hit it, we go like this. So there's your squiggle. And I'll put this one in really quick, as we have a 5th root. And that's what it looks like on here. Comes down, goes that way. Okay, so you have all these different shapes. You've got your parabola, which is your quadratics give you parabolas. Your square roots, 4th roots, 6th roots, 8th roots are all the same kind of idea, the dot with the tail. Then your absolute value makes what? A V. And then the only thing new we added is that odd roots, like 3rd roots, 5th roots, and 7th roots make what?
The squiggle you said.
The sideways squiggle. But you're still going to move those things left and right and up and down in the same fashion.